Good afternoon to everybody. Thanks for joining us for episode 3 on upgrading your productivity and enhancing that with MillBox Dental CAM. So today I'm going to be walking you guys through 3 simple features of MillBox that show you some of the benefits of having not only the latest and greatest version on here, but just to kind of show you those tools that we've developed over time and improved as well. So whether you're a pre-existing MillBox user that's on an old annual maintenance revision, you're going to see some newer features that may entice you to take advantage of those update possibilities. And if you're a Sum 3D user, which is our legacy CAM software that predated MillBox, there's never been a greater time to upgrade to MillBox. So you'll be able to see the stark contrast in features here as well. So just to kind of show you guys a general agenda about what we're going to be discussing today, we're going to be talking about the improved cutting simulations, spending a little bit of time talking about the simulation tool and how we can best use or leverage that to its fullest, and use that to improve your productivity and also to use for troubleshooting should you have any problems that arise during the milling process. The second piece that we're going to be talking about is our intelligent stock selection tool. So basically, when we're importing our restorations, we then have to import a disk to be able to nest that part inside of. And as we're selecting our disks, we're going to have an intelligent suggestion for what disk we're going to use, and we'll kind of go over how that's all displayed and how you can sort through all of those materials in your stock library very easily. And then last but certainly not least, we're going to be talking about smart and configurable support pins, talking about the various different types of support pins that are available to you. Some of these are unique to MillBox, and so we'll be discussing how that actually benefits you in your daily workflow. So now that is covers our agenda, let me go ahead and pull up MillBox, and we'll get started in talking about the CAM software. Okay, and now we have MillBox pulled up here. And what I'd like to do now, in this particular case, I've gone ahead and calculated this file. So this is just kind of pre-calculated just to save us a little bit on time here. Actually, let me, for some reason, my 3D mouse is not working. Let me just restart this real quick, get that fixed for us. And sorry for the delay. That's just going to take a brief 10-15 seconds here for me to restart that, and then we'll continue again. Perfect. And so what we're going to go ahead and do now is I'm going to just open that file back up that we were working with earlier. And again, this file's been pre-calculated. Now this is just a single crown. However, I did calculate it in 5 axes, so that way you could kind of get a little bit better of a view about how this would actually be executed on the machine. So I'll run the kinematic simulation just so that way we can show that. And as we're going through the simulation tool, I'll give you guys just a quick rundown. Now, we actually, in our manual, both in our online manual and on the manual that's embedded into the MillBox software, we have, I think, a 15 or 16 minute long video wherein we actually go through and explain every aspect of the simulation tool that you're going to use. But generally speaking, this is kind of like, imagine like a video, except this video is plotting and following the toolpaths that we generated during the toolpath calculation. So you can see, just like a video, we have a play button, we have a stop button, we have fast forward, and so on and so forth. We can control the speed of the simulation here. We have some visualization tools where we can kind of change the different angles here. We have visualization bars where I can turn certain things on or off. Like if I don't want to see, as an example, if I don't want to see my tool, I can simply click this to turn off the tool. Now, usually the only thing that I typically mess with up here is I just turn off the toolpath, and I'll show you why. I'll leave it on for just a second, just to show you what it looks like with it on. And then down here we have kind of like in a video, like I mentioned, it's like a little play bar, or a progress bar, and those are split up by colors. So each one of these operations in the top right-hand corner are listed out. Basically, these are all the cutting operations that are going to be performed. It's going to start with doing the roughing of the external of the crown and kind of work its way down to the finishing, all the way down to anatomical details, which are those optional steps on full contour cases. And each one of these operations is represented by a different color here in the play bar. So that's kind of how you navigate and use this simulation utility. Now, the biggest improvements that we've made here, of course, is you'll notice that instead of just having the fixture or the clamp around the disc, we now have the entire swing arm and rotary axis, as well as the automatic tool changer. And that's just important because from a collision protection standpoint, you want to have all those geometries in there. And the other improvement that we've made is we actually show the kinematic movements of the machine. Well, what does that mean? That means if the machine's actually going to tilt the disc back, we're actually going to see the entire disc itself tilt back. And so you can see here why the tool path is generally going to be, you're going to want that to be turned off, just because it's leaving the tool path everywhere that it traverses along that predetermined route. So turning that off gives me an unoccluded view of my restoration that's going to be roughed out here. Now, as we mentioned, I can increase or decrease the simulation speed to kind of get an idea of what's going to go on. But one thing you'll notice is I'm not touching my mouse or anything here. So one thing you'll notice, especially if you're a Sum 3D user, in the past, when the simulation flipped over, you actually had to kind of pause it, flip the simulation over, and kind of follow it. And this is the contrast with MillBox and the newer Kinematic simulation tool, is we'll actually rotate and pivot in the machine just as if the machine was running physically. So that gives us a much more accurate representation of what is actually going on inside of the machine and how this part is going to be milled out. So as you can see, I'm going down through the list and the play bar is continuing here. We're currently on the external finishing from the occlusal side, and then it's going to go on to external finishing from the cavity side. Now, if this is a little too slow for your liking, you can try increasing the simulation speed, or you can go in and just simply drag and drop it from the left to the right. And maybe I want to drop it into the next operation, which is going to be finishing the external cavity side. So then I can just simply hit play and continue watching it go here. Now, one thing you'll notice is when I pause it, the simulation quality is actually much better. Like, we have a much more accurate representation of what's going to come off of the machine here, and it automatically is refining the quality here, as you can see, and that happens whenever I pause the simulation or whenever the simulation is stopped. And the reason that it goes into lower quality when we're playing it is because sometimes we may want to pivot and turn it around. Now, does that mean that the quality of the simulation is not as good? Not at all. This is just simply a visualization. The simulation tool, as it's determining collisions and material removal, it's still working at that higher tolerance and lower tolerance. And the reality is, like I said, when I pause it, we get the dynamic update of that stock. So let me kind of fast forward it here, and I think the next one is going to be finishing of the internal cavity. So we'll actually just, I can also double click that and it'll take me to the start of that particular program or line in the program. And so we can see here, let me zoom out just a little bit, and this particular toolpath should engage all 5 axes, and then we'll actually be able to see that real-time kinematic movement, which is what we would expect to see on the machine. So we'll let it get down a little bit into that cavity. Okay, there we go. And now you can see that full 5-axis motion going on. So typically, when we're saying full 5-axis versus 3+2, this is what we're talking about when we say full 5-axis simultaneous. That means that all 5 axes in the machine are operating at the same time and in unison with one another in real time. So we have X, Y, and Z, which is controlled by the spindle. And then we have the A and the B axes. So those are all 5 of the axes total, and again, moving in unison together. 3+2 would basically be where we would index both rotary axes, and then we only have the 3 axes on the spindle going to work and coming in and milling that from an index position. So some important nomenclature to understand there, but you can see the importance of the simulation tool and how this is a great utility to use. If there's going to be a problem, like let's say you broke a tool or something like that, this will oftentimes give you an idea of where or why that broken tool may have occurred. And if it doesn't necessarily show it here, you can always kind of correlate where the tool broke and then come back into the simulation and try to pinpoint what may or may not have been a trouble point. And usually broken tools are typically going to be because the file was not processed properly, or it was missing some of the required criteria in order for it to be to properly calculate out. So that's the full 5-axis simulation tool. Of course, I can simply drag this progress bar all the way to the end. And if I do that, it kind of goes through the same process where it's just validating all the different cuts. And then here we can see my part is here. Now I chose not to mill out any of the 5-axis external undercuts. So this is actually how it would come off the machine had because I made that conscious choice to not mill these undercuts. So we'll show you what that option is that you need to select to be able to mill this, just to kind of clarify that for anybody if they're confused by that. But this is another reason why the simulation tool is very helpful, because if this came off the machine like this, and you're wondering, well, why did it come off the machine like this? And you're saying, okay, well, was it something physical that happened on the machine, or was it something that happened in the CAM software? And when you look at the simulation, if you see a discrepancy between what milled out and what your simulation shows you, then that definitely means something physical happened that we weren't accounting for. But if they look identical, then we know it was a direct cause or result of what we selected. So let me go ahead and close this out. And basically, for those of you that are not aware of how I would mill those external undercuts out in MillBox, let me show you how to do that. I'm actually running a test build today, and I'm running in pre-release mode because there's a new improvement that I'd like to show you guys in terms of the strategy option selection. So recently in 2021, we actually added a whole lot more data that you would see here when you go to select your strategy. And all of this used to kind of be in one straight line. So what you'll notice that we've actually done now with MillBox is we've separated all the statistical information about each of these operations over to the right. So that way you know, okay, what type of tool is it? Is it a cylindrical ball tool? Is it a conic ball tool? Is it a cylindrical ball tool? What's the diameter of that tool? What is the length or the reach of that tool? This is very important when you're talking about screw retain cases, understanding what the maximum reach of your tool is. And then this tells us what slot each of those tools go in. So this is super helpful information that you guys wouldn't have seen before in the previous revisions. And again, this is another reason why you want to keep your software up to date, or at least make sure that you always keep your maintenance active, so that way as these features become available, as this one has, people that have the 2021 maintenance can actually download this, and if you want, you can actually start testing this as early as today. So it's a really great change that we've done here. And so talking about the external undercuts, if we wanted those to be milled out, we could do those up to 30 degrees from the occlusal and or cavity side, and either or both of these operations would be enough to come in and mill out all of these undercuts that we had along the facial, because this was a cutback case. So that covers the changes and improvements that we've made to the cutting simulation. Of course, not only does that do those changes apply to the simulation, but you see those same kinematic movements in the machine as you're going throughout the nesting process. So everything is just a little bit more realistic in terms of what you're seeing occur in the CAM software versus the movements that you're going to see actually transpire on that machine as well. So very cool stuff there. So next we want to talk about intelligent stock selection. Why is this important? Well, as many of you know, especially if you're in higher production labs, you're going to run into challenges sometimes finding the proper discs. And this is where MillBox really kind of stands out and you can see some of our new AI features at work here as well. So there's two things that we want to do when we're going to select a new disk. The first thing is we want to check our minimum thickness that's required. Now this is going to be based off of the tallest restoration that I've imported into the disk. So in this case, this restoration it requires 11.39 millimeters in height, which means I know I need to select a 12 millimeter disc. And what you can see here is it's actually kind of pre-selected that, pre-highlighted that to kind of give me like, hey, this is a suggestion for where you can go to look. So I'm going to go and click on my partially used discs and make a selection. Now, the way that my partially used discs are kind of held in memory here is they're stored in descending order based on the percentage of how much of that disk has been used. So you can see down here, this disk has only been used by 3%. And we show the disk that has the highest utilization up at the top. Now, why do we do that? We do that specifically because if you are constantly selecting new disks and importing new disks of the same thicknesses into your library, you're not effectively, you're growing your partially used stock library, but you're not effectively using the disks that you've used before. So you want to use the disks that have been most used in the past, so you can get those out of your library and move on to those that have more and more space as you go along, and of course to the point to where you need to add new disks into that library. So you can see in this particular case, MillBox actually automatically selected this disk. So let me kind of go back a step and I'll show you how that works. So MillBox automatically selected that ZR12 disk named Mike at the top of my list. Now, if this disk, let's say, were 90% full, or let's say 99% full, where maybe it could fit another single case, but maybe just like a lower anterior, so like a really tiny restoration, but certainly maybe not enough space for this full contour molar with the cutback. And so if this were, let's pretend 90%, and then the next one down was 11%, it would actually skip that 99% and go down to the next one in the list, whichever one is most appropriate that this part would fit inside of. So that's another intelligent feature that MillBox does automatically for you, and it will automatically analyze all of your disks and present you with what it believes is the best option for what you're trying to accomplish. So that is some of the intelligent stock features that we've implemented. And one other thing as well, so if I'm looking for a particular disk, because as part of your stock creation process, you actually go in and assign names to these as well as lot codes. Well, if you've assigned a stock name or a stock ID to this, you can actually come down here, and this is very helpful for people that are running milling centers that maybe have a lot of various disks, and maybe you have, maybe you open up your partially used stock library and you have something in the neighborhood of 50 or 75 disks available to you. So easy way to kind of sort through that list and only show the items that you're looking for is you can just type in part of that disk name or the full name of the disk, and you would do that here down in the filter by file name, and that would allow it to filter out only the disks that match that criteria and the name. You can select that disk and then, of course, use it from that point moving forward. So those are some of the improvements that we made to the smart stock selection. One other thing that I didn't quite show there, and this isn't anything new in terms of MillBox, but in our settings, we do have a setting under the general settings area that will allow me to also show the positions of previously nested parts. So I'm just looking for that right here. So there's two different options we can do. We can group and separate our materials by machine. That can be useful if you are running, let's say, some roll-in machines intermixed with RM machines or VHF machines, and you just want to be able to separate those so that way you don't get the stock library mixed up. Or let's say you have an Amon Gerbach mill that has different material altogether. Well, you don't want that showing up for your standard discs. You can actually group that out by machine. And then let's see, let me scroll down here. I believe it may be a little bit lower. in this list. Here it is. So under blanks in our general settings, I can also show the previous locations for support pins on the blanks. And basically what that does is it just shows where I would have placed the support pin on a previous job that I nested in this disk. Now, what is the purpose of that, or why is that important? Well, that's really more or less important if you're doing batch processing, where you process a couple cases, nest those in the disk, get them calculating, and then while those are running on the machine, maybe you want to go ahead and calculate more jobs than uploads in sequence with that. So that way, after it gets done milling those, it automatically goes to starting to mill the next cases in there. This gives you a little bit more insight into your support pin placement. So that way, if you're going to be doing things like overlapping part borders, you know to avoid placing anything here, because if I had a restoration that hadn't been cut out yet in this position, and this is the placement of the support pin, well, by nature of me doing this with the subsequent job, when it's roughing, it will just rough this out and essentially will cut that connector off. The other restoration will fall down in the machine. So it's a really good indication, especially if you're using the same part borders from one job to the next. Well, then I can come in and do something like this, and I could rest assured that I'm not going to be causing a problem with this additional support pin because if I'm violating my part border or my offset, I can assume that the one prior had one similar in size, or whatever your default is. So if your default is 2.6 millimeters, then that's obviously what you want to take into account. You wouldn't want to violate that because then we could be roughing into or cutting the adjacent neighbor. So again, just some advancements on that regard. This display function has always been there for MillBox, but again, it's just a nice little perk to have whenever you need that. Okay, and the last, but certainly not least item that we want to talk about is going to be our smart support pins. So let's kind of discuss how that works, or our various different types of support pins, not just the smart ones. So what you guys see here are standard round support pins, and this is not going to be news for you guys that are using MillBox or Sun 3D. We've always kind of had these shapes. MillBox gives us a little bit more flexibility to adjust these on the fly, and that's why moving support pins in MillBox is like one click and drag and drop versus Sun 3D that used to take 7 clicks to drag, confirm that you're wanting to move it there, and then confirm the placement of where it actually placed it. So you can see the intuitiveness of moving these around are so much better. Also in MillBox, one of the unique items that we do is we'll actually show you any undercuts that would be created due to placement of your support pin. So if I was milling external undercuts as an option during my strategy selection, I'm not so concerned about these because the undercut operation will come in and mill those out. But 9 times out of 10, if you're working on full contour restorations, that's not always going to be your default. And so what you may want to do in that particular case is just one, make sure that your support pins are on this white line, which is kind of like our equator line, and make sure that it's not too high or too low below that line. So that way we're not creating additional material that has to be finished off after the fact. If I were to do something like this and I did not mill the undercuts, what will essentially happen is from the bottom of this shadow up to the support pin, you'll just see a solid strip of material where the tool didn't negotiate around that height of contour to come in and mill these blue shaded areas. So food for thought there when you're placing your support pins. Now, what about the different types of support pins that we have? Now, different materials have different requirements. Different types of support pins have different application uses. For zirconia, the traditional has always been the round or cylindrical ones. However, what I'm finding is really useful to a lot of people, whether it's zirconia or PMMA, are these smart support pins. So the smart support pins, and it may be a little bit difficult to see depending on your internet connection and how quick that's updating for you. But as I move this support pin left or right along this equator line, you can actually see that it morphs and changes shape in order to preserve that profile. And the reason we do that is we're doing that again to minimize the undercuts, because if I put it down here, I'm creating undercuts, right? And even if I'm using a rectangular support pin, then at some point I'm going to be creating undercuts somewhere, right? Because I'm not following that line. So it's better to use the smart support pin when you can. it's going to net you a lot better gripping strength on the part because we're holding it a little bit more laterally. And it's also a little bit easier to cut off because we're right there on that line, and it's a little bit thinner how it engages with the part versus something like a, you know, whether that's a 2 millimeter thick support. You can see the bulk of that is quite different versus our smart support pins. So in order to access those, all you have to do is just simply go in here and change the shape depending on what it is you're trying to accomplish, and MillBox will place that support pin in however you choose. So that kind of covers what the purpose of those smart support pins are. Now let's go into the settings, and I'll show you guys how we can do additional customization or configuration of those support pins. And we'll spend a little bit of we'll just spend a brief amount of time kind of discussing this because it's pretty straightforward. But if you go under the support pins tab in your settings, it's broken up by material, by object type, and then we have various different general settings based off of that. So let's say in this particular case, I think I was working on zirconia. So for a full contour crown, so I'm going to select full contour crown, and we'll select zirconia, which is pre-selected. So here we can see it's defaulted to use blue support pins, which are solid support pins. What does blue mean? Or what do the different colors mean? That's something we didn't really talk about. Before I go too far, I just want to quickly illustrate that. Blue means that these support pins are not going to be touched at all. They're going to be cut around, but we're not going to cut them off. Green means that we're going to completely finish those away from the surface after the milling process is done. That latter part is key. It's after the entire process is done. And then the semi-cuttable is just a partial reduction of that support pin after the milling process is completed, which essentially does a similar feat, except we're only coming in and trimming it in the middle, which makes it easier for you to take that support off of the machine or to take the restoration out of the disc when you're done. So going back to those settings portion, let's see here, support pins. Okay, so again, selecting full contour crown for my zirconia. Right now, I have a couple general parameters. There's my solid blue support pins. I like doing that, generally speaking, because it means less time on the machine. So the machine's not spending time cutting those support pins, and usually your technicians can cut those out very quickly and easily by hand. Just really depends, you know, because if you're doing an overnight run, then maybe you don't care because you won't be there while the machine's cutting. So, you know, just depends on your operation and your preferences on what you want to do. If you do partially reduced support pins, that's again going to take more time to mill those out, but that changes the default behavior of full contour crowns when I import those. And I can even say I want to assign one of those support pins as a green or a removable support pin as well. That's more similar. So like if you're looking for standard kind of some 3D behavior, these two options would have been what you would have expected. Disable reinforcement pins for glass ceramics. On the dry mill side, excuse me, you don't have to worry about that on the dry mill side. On the wet mill side, we create a reinforced support pin on pin block type material, and I would generally leave that on just because it's an extra safety function. It allows us to come in and hold on to the part with a little bit larger of a support pin, and we'll actually come down and reduce it at the end of the process. Similar to like what we do on the red, except we're finishing around the rim of the support pin and leaving a small little piece attached to that material. Now I can come in, I say, okay, I don't want to do any automatic support pins at all. I don't want the software to do anything. I want to always place my support pins on these restorations. When I do that, it turns off all of the automatic support pin functionality, and they'll just import without a support, and I have to go in and add them myself. Some 3D again is the default. Snapping pins to the equator curve, that is that white line that goes around the restoration. So that just automatically kind of lines it up in the vertical axis where it needs to be. And I can still come in and make some individual modifications about how I want support pins to act, whether I'm using a disc or whether I'm using a block or a pin block type material. Now that varies. These options that you're going to see here vary based on the material. So like if I select PEEK or even titanium, instead of doing pin block, With titanium, of course, those are usually referring to pre-milled abutments. So, there's all kinds of default behavior, how we're going to put the support pin position, and this is going to usually vary based off your pre-milled library provider. So, but if you need to access that for the various materials, they certainly are there. Now, the only other thing I wanted to show you guys here was under MillBox support pins. If I select that, that's going to give me a little bit more generic of options. And I'll tell you, this is not as intelligent, but it does give you something that's a little bit more basic. So really the only time that we use the MillBox support pins is typically on things like bite splints, and so like maybe in PMMA, and you can see it's set, basically what we do is we set a fixed distance between support pins of 10 millimeters. So every 10 millimeters of circumference around the part, we're going to place a support pin. We want a minimum of 2 support pins. We can put a max if we need to. And then we can say, okay, a percentage of those should be removable support pins, maybe kind of green. So 30% of those should be removable, so that way we're not having to cut off a bunch of those little pins. And then we can, of course, also make those snap to the equator curve as well, which is nice. So those are the default options that we have kind of set up for this down here. Of course, if we were using some 3D configuration and we're kind of going through and kind of setting these up by material, and let's say that I've gotten the material settings where I need them to be, I can actually simply go in and either apply this to all materials, or I can apply it to all other object types within that material. This I wouldn't use probably as much, but apply to all materials you could theoretically use once you've kind of gotten your per object type preferences enumerated there. So for most people, the automatic support pins are going to work for majority of people out there. There are some people that have specific preferences, and so MillBox can accommodate you in either of those scenarios. So that covers pretty much everything that we had here to show you guys today, and really appreciate your attention. And of course, if there are any questions open, I'd like to open up that opportunity to answer those now.
Sure, thank you so much, Mike. There are a couple of questions. The first one is, if I haven't upgraded in the past 3 years, do I have to pay for all 3 years to catch up?
That's a great question. So originally originally the answer would have been yes a few years ago if you had asked me. Recently we had put in a limit or a cap of 3 years maximum annual maintenance. So if you're over 3 years, the most you would ever pay is 3 years. Right now there is a promo, and it's literally about to end in a few days. So reach out to your Zahn rep and check in with them, but it's very well possible, depending on your license, you may be able to get that for as close as possible to 1 year of annual maintenance. And there's a lot of value in some of those promos going on right now. So just really depends on what your dongle is provisioned for, but definitely contact your sales rep, give them your dongle number, and have them look that up with us, and they can give you a better idea on the exact cost of that. But right now there's a specific promo that falls under, so you want to be, it's very time sensitive. I would get on that if you can.
Okay, perfect. That was another question. They wanted to know what if there was a promotion, how long it was going to be. And also, do they upgrade through Zahn, or do they have to contact someone at Sim? And you answered that, to call the Zahn representative, so that's great.
Correct,
there is one more question. Can I upgrade all at once, or is it a series of upgrades?
Great question. So generally speaking, when you upgrade, I imagine by your question, it sounds like you're a few versions behind, or maybe even a few years behind on annual maintenance. So right now, under that promo that we were just mentioning, it would be a single upgrade. So you could do it all at once, and we would just send you, so the way our updates work, our dongles are perpetual licenses. And this is a little bit extra tidbit information for all the owners out there. Your dongle doesn't dial home. All the licensing is actually on that little USB key. So because of that reason, you'd never want to lose those dongles. So make sure that you hold on to those, because they can't be replaced unless they're damaged, where we can, you can ship it back to us. We can verify it's original, then we can replace those. But in terms of how we update them, returning back to your original question, we would just simply provide your dealer with a single write-only file they drag that over and put it in your installer, and then they relaunch MillBox. That file goes away and your dongle updates, and then now you have capability to run the latest versions using your permanent license. And in the meantime, for that, let's say that you've decided, I want to go ahead and get this upgrade, I want to go ahead and start using this newest version. You can definitely arrange for that with your Zahn rep and their technical support team. They can get you the latest version and generate a temporary license for you for 30 days or whatever the period is that it's going to take to fulfill your order, and then they can get you up and running, as soon as they can connect with you to get that done. So you don't actually have to wait for the upgrade to process to be able to take advantage of these features.